Recording. Okay. Hello. Happy Tuesday if you're watching this on Tuesday. Hi to the two of you who have showed up. Quick announcement. When I updated our homepage on yesterday, I made a typo and I fixed the typo, but it's still in the announcements. It's still incorrect on when test 2 is. So I said that test 2 will be open Friday, October 28th through Friday, November 11th. And it really should have said Friday, November 4th. It's a small typo. It still opens on the 28th. It's just that test 2 doesn't end on the 11th. It ends on the 4th. Anyways, it's fixed on the homepage. Test 1 is over. It's out of our lives, right? We can move forward, and test 2 begins October 28th, so we have some time to breathe, which I guess is only 10 days. Feels like it's 10 days is a lot of time, right? I need to keep my phone open. I forgot to drink coffee this morning. Not forgot. I remembered, but I was already out the door, and now my brain isn't working. My husband's going to bring me coffee at some point, so I have my phone out. There's no way he's going to be able to do that. My son's going to be taking a nap. There's no way I'm getting coffee today. It's okay. We'll manage. All right. So we're going to start talking about lines. And this worksheet I posted. So hopefully you guys have printed this out. It's posted on our homepage. You can see it. It's the lines worksheet. If you don't have it, it's not a big deal. A lot of it can be copied down. It's just more convenient. Now, this first page, I believe we've already done these exact problems, but it was really at the beginning of class, and we're going to start back here. So 2.3 is lines. And by line, I mean a line, right? Lines. This is what we're talking about. You'll notice that there's a lot of pages here to this worksheet, and that's because I've made this worksheet to be used in a video, not to be used with students, but I liked it enough that I'm making it with students. But there's a lot of blank space in it, is what's happening here. There's a lot of blank space in this worksheet. There's a lot to talk about lines, though, because there's a lot of properties that lines have. You might think, oh, how many properties could a line have? A lot. So let's start talking about them. Let me get my own notes up. There you are. So we're going to start doing something we've done before, which is filling out this table using these x values and this equation right here. This is going to end up being a line. Well, let's fill out the table and graph it. With this, you are plugging in this x value to this equation. So you would be doing something like 2 times whatever x value, leave a little room, minus 4. Need to leave a little more room because I need room to write the answer. And I'm going to just duplicate this for each row because we're doing this for each x value. We're going to be plugging in an x value, getting out a y value, making a coordinate point, plotting it. So for x equals -2, we plug in -2 for x. So we have 2 times x is -2 minus 4. That's -4 minus 4, which is -8. So we have the coordinate point, -2, -8. And we'll plot a point. Plugging in the x value, -1. 2 times -1 is -2. -2 minus 4 is -6. So we have the point -1, -6. Plugging in the x value, 0. 2 times 0 is 0. 0 minus 4 is -4. So we have 0, -4 as another coordinate point. Plug in the x value 1. 2 times 1 is 2. 2 minus 4 is -2. So we have 1, -2. Lastly, if we plug in the x value 2, we have 2 times 2 is 4. 4 minus 4 is 0. So we have 2, 0. Oh, and I forgot to plot. Let's see, this guy, this guy. So there's something interesting happening here. There's something interesting happening here with the y values versus the x values. In particular, notice that the y values, -8, -6, -4, -2, 0. These y values are all going up by 2 each time. Each time x goes up by 1. X goes up by 1, y goes up by 2. Right? This is like adding 2 to the y value. I will not be getting coffee. Ah, I knew it. That is a disappointment. My brain is not happy right now. You know what? Actually, I might have some. Give me a second. It's okay. I have 34 milligrams of caffeine in this Diet Coke. It's Diet Coke. All right. So the y value is going up by 2 every time that x value goes up by 1. And if you'll notice, in this equation, next to the x, there's a 2. Keep that in mind, all right? Just kind of keep in mind. Let's fill out the next table. But I want you to keep in mind everything we said. X value is going up by 1, y value is going up by 2, and the number that just so happens to be right next to the x is 2. So we'll look at this next one. Doing the same thing, we're taking x values, we're multiplying them by -1/2, adding 1, and getting a y value. So plugging in the x value -2, you're going to just have to trust me on this math because most of us aren't going to do fraction math in their head. I'll do the fraction math in my head. You can use a calculator, but -1/2 times -2 is 1. 1 plus 1 is 2. So we have the point -2, 2. -2 is the x value, 2 is the y value. -1/2 times -1 is 1/2. 1/2 plus 1 is 1.5. 1.5 is what I'm going to write. So -1, 1.5 would be right here. Bam. Plugging in 0. -1/2 times 0 is 0. 0 plus 1 is 1. We have the point 0, 1. Plugging in 1. -1/2 times 1 is -1/2 plus 1 is 0.5. So we have 1, 0.5. Finally, plugging in 2, -1/2 times 2 is -1. -1 plus 1 is 0. We get 0.20. And we can connect the dots. Come on, Mr. Line. There it is. So here, every time the x values go up by 1, the y values are going down by 1/2. Right? We went from 2 to 1.5, 1, 0.5, 0. Each time they're going down by 0.5, which is interesting because right next to this x, there's a negative 1/2. And up above, right next to the x, there was a 2 and it went up by 2. There was a positive 2 and it went up by 2 each time. When this number next to the x was a negative number, it went down by 1/2 each time. That number is really important, and we call that number the slope of the line. The slope of the line simply tells us how much the y value changes by every time x increases by 1. So I'm going to go back up to this original example and write down here. So we say that the slope of the line, the slope of the line is 2. And down below, we can say that the slope is negative 1/2 because every time x increases by 1, y decreases by 1/2. And that means that the slope is negative 1/2. Right. So if your slope is negative, if x increases, then y will decrease. And if your slope is positive, then when x increases, y increases. So positive slopes make the y values go up. Negative slopes make the y values go down. Exactly that. No problem. So it gets generalized a little bit more than that. And if I scroll too fast, just tell me so I can scroll back up. I'm always so concerned about that, but it's just hard to tell where people are. Let's see, stickers. So slope is a little bit more than that. It's not just, x going over by 1 and what y does. It's even more. It's how much your y values change versus how much your x values change. And we define it in this way, and this statement might sound familiar somewhere. Boop, 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 come back. That the slope is the rise over the run. It's how far the line rises over how far it goes to the left or right. Another way of saying that is it's the change in y values over the change in x values. At its most simple form, it tells us what happens for a single unit of fx. If x increases by 1, y does this. But it can be derived from much bigger changes in x than just 1. So, for instance, when we go from this point, let's go up here a little bit. When we go from this point right here, if we go over 2 units, 1, 2, we go up 4 units. 1, 2, 3, 4. So when x changes by 1, we go up by 2, y goes up by 2. When x changes by 2, y goes up by 4. So that ratio stays the same throughout the entire graph. That's what makes it a line. So it's the change in y values over the change in x values. So if I draw a line right here, and let's say that to get from this point here to this point here, there's no numbers, I'm making them up right here. Let's say that it took me 3 units to get up from this point and 2 units over. If that's, that line is crooked. But let's say to get from this one to this one, we had to go up 3 and over 2. We call this number here the rise. And this number here, the run. So the slope of a line, of this line, would be its rise over its run, which would be 3/2. And you can choose any 2 points on the line to do this with. And if this is feeling confusing, no problem. We're about to go up and we'll talk about it. So I'm going to scroll up here for just a moment. I can choose any 2 points on this line. Let's take this guy right here and this one right here. To get from this point to this point here, I would need to go up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 units up. And then 1, 2, 3, 4, 5 units to the right. And what do you know? The rise, 10, divided by the run, 5, simplifies down to 2. If I take this point here and this point here, I'm going up 1, 2, 3, 4, 5, 6 units up, and 1, 2, 3 units over. The rise is 6, the run is 3, the slope is 2. Any 2 points on this line are going to simplify. The difference in the y values over the difference in the x values is going to simplify to 2. Pretty cool. It's true of this line down here. Take this point here and this point here. I go down 2 units. And I go 1, 2, oh goodness. And I go down 1, 2, 3, 4. So it's 4 units to the right, and 2 units down. The rise is -2, the run is 4. That simplifies to -1/2. We can go big. We can make a different type of triangle. We can go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 units this way. 1, 2, 3, 4, 5, 6 units down. Change in y values was -6. Change in x values was 12. That simplifies down to -1/2. It's pretty cool. It's pretty cool. So this is true of any 2 points you choose on this line. That's what makes it its slope. And that's what the slope does. A few notes about slope. One, and this is a rule I'm giving you. It's not a rule in general, but always start with the leftmost point. Always start with the leftmost point. Notice with all of these ones, when I started counting, I was always starting with the left point and I moved to the right point. The reason for that, if we always start with the left and go to the right, we know that the run value is positive. So the only thing we have to determine is if the rise is positive or negative. And in this case, like if you go down, the rise is negative. If you go up, the rise is positive. So starting with the leftmost point allows you to say that the run is always a positive number. There's ways to make the run a negative number, but we're not talking about them. That's not how I teach it. But if you want to look it up online, it does exist online. The rise is either positive or negative, and it depends on if you go up or down from the first point. So we have some examples right here for us to try. I'm going to do one, and then I'm going to let you guys do the other two to practice. But I'm starting with this point right here. And I'm going 1, 2, 3, 4, 5 units this way. That's my run is 5. And then I have to go down 1, 2, 3, 4. I go down 4 units. So my run, my rise, is -4. Slope is rise over run. So the slope of this line is -4 fifths. I chose negative here because I had to go down if I was going up instead. And I would have had to go down if I made it. It doesn't matter which I did first, rise or run. If I did rise first, I would have gone down still. It's just a matter of where the run is. So try these other two real quick and let me know when you're ready. Yes, if a fraction reduces, reduce the fraction. But exactly that. So starting here, we're going up 1, 2, 3. Going to the right, 1, 2. The rise is 3. The run is 2. Over here, starting with the left point. 1, 2, 3, 4 units down. Negative. Can't even see it. Not that it matters. I know you guys have it. So -4, and then 1, 2, 3, or not 2, sorry, 1, 2. You get -4 divided by 2, which is -2. So the important part though is that it is negative because we're going down. Over here we went up, so that was positive, but if it's down, it's negative. Does that make sense? Are there questions? Can I answer any questions? Oh yeah, it's don't worry. Don't worry. There will be so much practice. You'll be sick of hearing about you'll be sick of lines. You'll be a pro at them. I don't get sick of teaching lines though. Lines are fun. Lines are a lot of fun. The rules are very concise, which I really like about lines. So then there's the question, do I have to graph a point to find the slope of a line? And the answer is no, even though that's not how I worded this question here. So the way I worded this question is, can we find the slope without graphing? Yes. We don't have to graph to find the slope of a line. There is a formula. Now, we had previously said all of this stuff up here. Duplicate. Come down with me. We had previously said all of these things here. Let's pretend that these 2 points that we have, point 1 is going to be x1, y, y1, and point 2 is going to be x2, y2. These are the points. These are subscripts right here. So these are, if you think of like a superscript, like if you're writing that something is squared, that's a superscript. This is a subscript, so it's below the, it's not x2, it's x2. And that just denotes that there's another x. So we have x1, y1, and x2, y2. Those are the 2 points, and we're saying, hey, here's 2 points on a graph. What's the slope between these 2 points? I'm going to draw a picture real quick. So let's say right here that this is the point x2, y2, and that over here is the point x1, y1. If we wanted to find the change in the y values, we would look at the y value here. So this is y1. And the y value here, which is y2. The difference between these 2 values is going to be the bigger y value minus the smaller y value. Yeah, we'll just leave it that way. I want to put in some stipulations to that, but I'm not going to. The difference between these is y2 minus y1. If we take the y2 value and subtract the y1 value, that'll give us the difference between the change in y values between these 2 points. So if we look at these points up here real quick, this guy had a y value. This is the point. This is the point 1, 4. This is the point -1, 1. If you subtract 4 minus 1, you get the rise, which is 3. And you can see that something similar is going to happen with the x values too, because 1 minus -1 is 1 plus 1, which is 2. And it's true of these negative numbers too, because this is the point -2, comma, -1. This is the point 3, comma, -5. If we do -1 minus -5, or sorry, it's not the bigger y value first, it's the second y value first is really what it is. It's the second y value. So this is the second point. -5 minus -1 is -4, because you would add 1. So this works even if the numbers are negative, is the point I'm trying to make. So that rise is really y2 minus y1. And the change in the x values, well, this right here is the x value, x1. Right here, this is the x value, x2. And the difference in these two x values is x2 minus x1. And that, my friends, is the formula for slope. That's it. That's it right there. So if you have 2 points and you want to find the slope between them, you say that one is the first, the other is the second. So when I was doing this picture here, when I was doing this picture over here and I said, okay, well, it really has to be the second point, that's because I don't want my run values to be negative visually. But if you had done this problem, -1 minus -5, and then -2 minus 3, you would get -1 plus 5 over -5. You would get +4 over -5, which is the same value as -4 fifths. -4 fifths and 4 over -5 are the same value. It's just the negative is flipped sides. So it's really not that you have to do the second point first. It's just that if you want your run values to be positive, you do. It doesn't really matter, though, which point is first, because it all comes out the same. It just might be the negative flip-flops. So we'll do an example. We have a point 5, 2, another point 4, 3, -3. It doesn't matter who is who. I'm going to say that this guy is my first point. So I'm going to say x1 is 5, y1 is 2. And for this point here, I'm going to say that x2 is 4 and y2 is -3. So I've essentially done this. x1, y1, x2, y2. My formula for slope, y2 minus y1 divided by x2 minus x1. So y2 is -3 minus y1 is 2 all over x2 is 4, y2, or sorry, and x2 is 4, x1 is 5. We get -5 divided by -1, which comes out to be +5. So the slope between those 2 points is 5. It is simply a formula, and then you just choose which point is going to be x1, y1, which one's going to be x2, y2. Again, I could have flip-flopped these because if you flip-flop them, here's what you get. If I instead said that x1 was 4 and y1 was -3 and x2 was 5 and y2 was 2. So I'm flip-flopping these guys and these guys. If I were to do that instead, my slope would be 2 minus -3 all over x2 minus x1, which is 5 minus 4. So we would have had 2 plus 3, which is 5, all divided by 1. That comes out to be 5. Same answer. Same answer. Now, I would love to give you guys a chance to do a slope example, but I do want to make sure we get through all that I want to get through. And there's going to be examples of it later in this worksheet. So I think I'm just going to keep going. But can I answer any questions before I move to the next page? Okay. So let us talk about the slope-intercept form of a line. The slope-intercept form of a line, you may have heard it's y equals mx plus b, where m is the slope of the line and b is the y-intercept. Which is where the line crosses the y-axis. For the slope is just the coefficient on x. It doesn't include the x itself. It's just the coefficient on the x. So we'll look at some examples. First of all, we could go back to the very first view that we did. I'll come back to this page, but if we go back to the very first view, this is y equals 2x minus 4. The slope would be 2. The y-intercept would be -4. And let's look. Indeed, the line crosses the y-axis at -4. The slope is 2. It crosses the y-axis at -4. Here we have -1/2 x plus 1. The slope is -1/2. The y-intercept is +1. Let's check. Yep, the y-intercept is 1, and we already knew the slope was -1/2. So let's do an example. For this guy, what is the slope? What is the slope? It's always the number next. Yeah, so not positive 3/4, but perfect. Negative 3/4. So it'll always include that. If there's a negative in front of it, we'll include it. So the m value, which is the same as slope, slope is negative 3/4. What is the y-intercept? Beautiful. I should have wrote b. b equals 5 is what I should write. So that one, easy peasy. This next one is not in slope-intercept form. Slope-intercept form has to be y equals mx plus b. And this is not in y equals mx plus b form. We're going to need to rewrite it that way and solve for y. And so we're going to solve for y. And here is how it looks. We're looking to get y by itself. I'm going to highlight the y. We're looking to get y by itself. So basically anything that isn't y needs to go away. We're going to subtract 6x on both sides. That'll make these 6x's cancel. We have 3y is equal to negative 6x plus 15 is how I'm going to write it. That's the same as 15 minus 6x, but written in a different way. And then I'm dividing both sides by 3. To get the y by itself. This 3 gets distributed to both denominators, so it really becomes negative 6x over 3 plus 15 over 3. And negative 6x divided by 3 is negative 2x. 15 divided by 3 is 5. I guess I should do this on this line here. So if y is equal to negative 2x plus 5, that means the m value is negative 2. The b value is 5. So the slope, which is m, is negative 2. The y-intercept, which is b, is 5. So again, on the math here, we started by subtracting the 6x to the other side. That gave us 3y equals negative 6x plus 15. To get rid of the 3 in front of the y, we divided both sides by 3. On this next step, I took the 3 and I distributed it between each of the terms in the numerator, and then I simplified the fractions. So what do we think about this next one then? It's y equals negative x, right? Y equals negative x. I know it's kind of tight in there. What do we think the slope and the y-intercept are? What is the slope? Just the slope on this one. Not positive one, but beautiful. Yes. So really, this could be rewritten as y equals negative 1x plus 0. They're the same statement. If there's nothing in front, it's a secret one. So the m value is negative 1, and the b value would be 0. So slope is negative 1, y-intercept is 0. And we'll go down if we're feeling ready. And we'll do some examples of graphing, because it's actually like, it's super awesome. Oh man, that's not on this worksheet. I have to write that by hand. Dang it. Okay. Annoying. There's something I put on the worksheet later that had some steps written out, but I'll just write them out by hand. So this is fun. I promise this is fun. And I know there's fractions and you might be like, oh, fractions, but I promise it'll be fun. So for each of these problems on this page, we're finding the slope, we're finding the y-intercept, we're graphing the line. We're given this function y equals 5/3 x minus 4. The slope is the number right in front of the x, so the slope is 5/3. The y-intercept is this guy here. M is 5/3, b is negative 4. So the y-intercept is negative 4. Here's what you do to graph. Your first step, your step 1. You plot the y-intercept. Okay. Y-intercept is at negative 4, so at negative 4 on the y-axis, I plot a point. This is my first point. Then you plot your second point by using the slope, and we're going to use the slope in an interesting way. But we plot the second point by starting at the y-intercept. Where's it? Why is my, okay, like disappearing on my screen? It is disappearing. That's weird and a little uncomfortable. Hope that's not ruined. Okay. Start at the y-intercept, and then you use the slope. And here's how we're using it. Oh no. Oh, my nib came loose, that's why. We know that slope is rise over run. And we know that this is true between any points on the line. We can choose any 2 points on the line, and the rise and run to get to the next point are going to be the same. Or at least the ratio. You know what I'm trying to say there. So the rise is 5. The run is 3. We can start at this point right here. Rise 5 over 3 to plot another point. So we would go, let's do, maybe a highlighter would be better here. We go up. Did I go 5? Oh, I went too many. Hold on. Too many. We go up 5 units. 1, 2, 3, 4, 5. Up 5. And then we go run is 3. 1, 2, 3. And I plot my next point. So we go up 5, right 3. You can continue going up 5, right 3 to plot points. So I can stay at this point here, go up 1, 2, 3, 4, 5, over 3. 1, 2, 3. You can see the pattern, and it allows you to even go in the negative direction if you'd like. It's going to look a little different. So you're going to be going backwards 3 and then down 5, but you can do it. And all you need to graph a line in the first place are 2 points. That's all that a line needs. Once you have 2 points on a line, that's the entire line. And I guess the step 3. Okay, let me write stuff down. Step 3 is just draw the line. Draw the line. Connect the dots. So this is my second point. Again, I plotted the y-intercept. My slope is 5/3, so rise is 5, up 5, run is 3, right 3, plot another point. That's enough to draw the line. I drew some additional points here. You don't have to, but you can continue going up 5, right 3. Or if you want to go in the reverse direction, it would be down 5, left 3. So this process goes really, really fast. The rest of this work of this page can be done quite quickly. For the next one, we have y equals 3x minus 5. So the m value is 3. The b value is negative 5. That means our slope is 3. Our y-intercept is negative 5. I'm plotting my y-intercept at negative 5. That's right here on the y-axis. My slope might not look like it's a fraction. So how could I do this if my slope's not a fraction? Well, 3 is actually the same thing as 3 divided by 1, because anything can always be put over 1. We can always put a number over 1. So the rise is 3, the run is 1. starting at this point here, we go up 3, 1, 2, 3, to the right 1, 1. Plot a point. Again, I can continue doing this. Up 3, right 1, up 3, right 1, up 3, right 1, up 3, right 1. Or down 3, left 1. And draw the lines. This was up 3, and this was right 1. And that's it. That's the whole line. It's kind of fun, to be honest. I feel like they're a little bit fun. So for this next one, I'd like for you to try it. I know it looks a tiny bit different, but I'd like for you to try graphing this one on your own. I know the y-intercept might seem mysterious, but I think you can figure it out. And if not, I'm going to go over it in a minute. But try graphing this line. Find the slope, find the y-intercept, graph the line. Oh, and maybe I guess I need to tell you the important point. If you have a negative slope, the negative goes with the rise. So if you have -2/5, you want to look at it as the negative on top. 2/5. Okay, give it a shot real quick. So I'm gonna start writing here. There's a secret +0, so the y-intercept is 0. For -2/5, this would be down 2, right 5. So my y-intercept is at 0. That's the origin. Down 2, right 5. I can do that again, down 2, right 5. And if I want to go in the opposite direction, you're just doing the opposite of these. So instead of down 2, right 5, it would be up 2, left 5 if you're going in the left direction. It should follow the pattern though. So I could go up 2, left 5, up 2, left 5. The good news is on Alex, you only have to plot 2 points. So it's quite quick. Did that go okay?
My brain took a minute to catch up, but yeah.
It's going okay. And we'll be doing there's a lot to come. So can I answer any questions though?
No, I just needed to, for me, I just needed to look at it and go, hold on, wait, this is, I think I was making it too complicated.
It's one of like because we've done a lot of complicated things too. I think that makes it harder because it's like, okay, we've done a lot of complicated things, and this one is it's almost like it's there's some things that are a little tricky, but like for the most part, it's like, is it really that like it can't be just like that easy, like that number does that when we've done so many hard things. But let's look at this next page here. This is finding the equation for the line in slope intercept form. So we're looking for y equals mx plus b. So we need to find the m and the b. It's not bad doing this. So for the b value, that's the y-intercept. So here, the y-intercept is -3. To find the slope, you can pick any other point on the line. So I see that there's a point here. You're just looking for anywhere where the line crosses the grid. As long as you have 2 points on the line, you can find the slope. So from this point down here, my y-intercept, I need to go up 3, right 1. I started with the left point, went to the right point. So my slope, rise over run, it goes up 3, right 1. My slope is 3. So the equation here is y equals, the slope is 3, then we put an x, y-intercept is -3, and that would be the equation. Looking at this next one, the y-intercept is at -4. That's going to be our b value. B is -4. And then we need another point on the line. I see that this one seems to hit the grid in a nice spot. It hits the grid at -3. So I'm starting with my left point and I'm going to my right point. Starting with my left point, I'm going down. So 1, 2, 3, 4 units down, which would be -4. And then 1, 2, 3 units to the right. So my slope, down 4, right 3. And that's my m value. As an equation, don't forget the y equals. So we have y equals, the slope is -4/3 x plus b, which is -4. Give this next one a try. Give the next one a try. Give me your answer in the chat box. I would agree with you for the slope. I would agree with that. I'm going to get 2 points on my line. So I have a point here, a point here. It could honestly be any points. I could go down here too if I really wanted. So the y-intercept is at 1. That is your m value. Starting with the left point, we go down 1, 2, 3. So this is -3. And then to the right, 1, 2, 3, 4, 5, 6. 6. Slope is rise -3 over run 6. That simplifies to -1/2. Oh, what am I doing here? This is an M. This is silly. Fully lost. This is B. This is M. Okay. So do you understand where the y-intercept is coming from? Okay, so the y-intercept is just wherever the line crosses the y-axis. So the line right here, it crosses at 1. So that was the y-intercept. Up here, it crossed at -4. And that's why we have a -4 here. And here, it was at -3, which is why there's a -3 there. Does that help a little bit with that? And it's the same here. The y-intercept was 0. Here, the y-intercept is at -5. So if we look at the equation, we had a -5 here. So that's where the y-intercept is coming from. And then the slope, we always start with the left point, and then we go to the right point. So our rise was -3. This was the 2 points I chose. You could choose other points. You got the right slope. It's -1/2. So you're going down 3, right 6 for the 2 points I chose. So it was -3 divided by 6, which simplifies to -1/2. And as an equation, we'd have y equals -1/2 x plus 1. Does that help a little bit? Oh, the plus, so yeah, so that's the y-intercept. So that is this value here. So it's always with the y, it's always y equals mx plus b. Since our y-intercept was positive, that's where that turned into the +1. The m value was -1/2. The x just comes down, and then it's y equals -1/2 x plus 1. So it's because that's where it hit the y-axis there. So it hits the y-axis right here at 1. That's where the line crosses the y-axis. So that's where the 1 is from. So wherever they crosses the y-axis, that's what the number at the end is. So right here, the line crosses the y-axis at -4. So we put a -4 at the end. And up here, When the line crossed the y-axis, it was at -3. That's where it crossed. So we put a -3 at the end. So if you pause it up, so if I choose a different point, it could be a different, no, because the line is only going to cross the y-axis in a different point at one point. You might not choose to use the y-intercept to find your slope. You don't have to use the y-intercept to help you find your slope. You could use different points, but the y-intercept is always going to be, this is the y-axis right here. It's always going to be the place where the line crosses the y-axis. So there's only one answer for any of the graphs. If we come up to here, we look here, crosses at -5. So it should be a -5 in the, yeah, good, excellent. So one of the traditional problems you're going to see, this is like a classic algebra problem, a classic that you end up seeing in a lot of other math, is finding the equation of a line given 2 points on that line. So we're being told, hey, these are 2 points on the line. What is the equation? What is the y equals mx plus b if these are 2 points on the line? It would be like being told for this graph here, hey, there's the point 0, 1 and the point 6, -2. What's the equation of the line? And it ended up being this. So your first step here, you need to find the slope of the line. There's no picture. Boring. No picture. Step 1, find the slope of the line using the slope formula. Maybe I should just make that all blue. So slope, which is the m value, is y2 minus y1 all divided by x2 minus x1. x2 minus x1. I'm going to use these guys as x1. x1 is 1. y1 is 2. x2 is 3. And y2 is -5. It doesn't matter for these ones. If you chose these to be x1, y1, and these to be x2, y2, you would end up with the same answer. What's really important, you don't want something like x1 and y2 being together, because that's not how the coordinate points work. So as long as you, from any given coordinate point, it's either x1, y1 or x2, y2, you're good. Plugging in those values, y2 is -5 minus y1 is 2, all divided by x2 is 3 minus x1 is 1. So we have -7 divided by 3 minus 1, which is 2. -7 divided by 2. That's the slope. The m value is -7/2. So we could say, hey, I know the m, I know it's not 5/2. I know it's -7/2. All that's left to find now is what b is. We need to figure out what b is. And if we're not graphing, it's a lot more difficult, because with the graph, you just look at the y-axis. Where does the line cross the y-axis? That's the b. Doing it algebraically, we have to be a little bit more creative. And the way we do it is by plugging in one of these points to this equation and solving for b. So let me write down the step. Use y equals mx plus b, and plug in slope for m. And one of the given coordinate points for x and y. It doesn't matter which coordinate point we choose to do. You can choose 1, 2, or you can choose 3, -5. I'm going to, our m is stagnant. Our m is -7/2. I'm going to choose this first one, 1, 2. The point on the line I have is 1, 2. So in order to draw a line, you need either 2 points on a line or the slope and 1 point on a line. Those are the things that you need in order to find the equation of a line. So I'm going to let x be 1 and y is going to be 2. We are plugging in to the equation y equals mx plus b. Plugging into the equation y equals mx plus b. M is -7/2. Y is 2. So we have 2 equals -7/2. Instead of x, I have 1. And I don't know what b is. So this plus b right here comes down here and it's still plus b. So we're solving the equation. 2 is equal to -7/2 plus b, finding out what b is. To get b by itself, I'm going to add 7/2 to both sides. And I'm just going to tell you that that comes out 2 plus 7/2 is 11/2. I'm just going to claim that. So your b value is 11/2. So we have an m value, we have a b value. That's all we need. If you have m and b, you just put it into slope-intercept form. M was -7/2. B is 11/2. So our equation of our line is y equals -7/2 x plus 11/2. Is it a nice line? Not quite. It's kind of a nasty looking one, but it's what it is. So this is it's a harder type problem. There's a lot of steps here, and I want to go over it one more time. We started with 2 points on the line. In order to find the slope-intercept form of the line, which is y equals mx plus b, we need a value for m, which is slope, and we need a value for b, which is the y-intercept. So we started with finding the slope, which is m. The slope formula is y2 minus y1 over x2 minus x1. So we plugged in these 2 points into the slope formula. We found that the slope was -7/2. To find the y-intercept b, it's more difficult because we're not graphing it. So we take data that we know is true. We know that the point 1, 2, which was up here, is on the line. 1, 2 is on the line they told us it was, which means that if I plug in 1 for x and 2 for y and plug in the slope, that I could solve for b. So I did that. I plugged in 2 for y, 1 for x, -7/2 for m, solved for b. Once you have m and b, you can plug them in to y equals mx plus b, and that's the answer. So right now would be a great time, I think, to take a break because the next thing is working on another portion of the worksheet. So why don't we do that? Why don't we take a small break? And we'll return by 12:35. And if you have questions, go ahead and look over everything. And if you have questions, then we come back, we can answer them. Otherwise, we'll move on to intercepts of lines, which is the next portion of the worksheet. I'm gonna stretch and stuff. All right, see you in a moment. All right, we're back. It is 12:35. I found myself an energy drink and a vending machine, so I'm excited because that is not, it's not even 100. It's not even 100 milligrams of caffeine, but you know what? It's more than this Coke Zero, so I'm excited. All right, let's talk more about lines. Are there any questions I can answer before we go forward? I'm laughing because for those of you in the future watching it, it's just me and Jenny. There's just one student here, so I'm talking like I'm talking to a class. There's not a class. Okay, all right. We'll move forward then. All right, so let's talk about intercepts of a line. We talked about the y-intercept. We said that that's where the line hits the y-axis. An x-intercept is where a graph hits the x-axis. I think we talked about x-intercepts. I just can't remember if we have or not. But x-intercept. Okay, yeah. I teach Math 126 and Math 124, and we're on different trajectories. So those are both classes that are almost identical, but not quite identical. And they've talked about x-intercepts. I don't think we have in this class. I think you're right. This is where the graph hits the x-axis. So the x-intercept is where the graph hits the x-axis. The y-intercept is where the graph hits the y-axis. If I look at if I scroll up for just a moment, in this problem here, the x-intercept would have been 2. The y-intercept is 1. The x-intercept is 2 because that's where it crosses the x-axis. If I look at this graph here, the y-intercept is -4. The x-intercept is -3. Notice, so this is the point, -3, 0. The x value is -3, the y value is 0. It is a requirement of x-intercepts that the y value at that coordinate point be 0, because if the y coordinate's not 0, then it's not the x-axis. Likewise, with y-intercepts, this is the point 0, -4. And with y-intercepts, the x value needs to be 0 because the y-axis happens at x equal to 0. So any y-intercept is going to have x as the x coordinate will be 0, and any x intercept will have a y coordinate that is 0. And I'm going to write that down. I'm going to write it down here. So this is like blank comma 0 for the coordinate point. And this guy right here would be the x-intercept. So the x-intercept is where y equals 0. So we can solve for the x-intercept by plugging in y equal to 0 to this equation. So we can plug y equals 0 into x plus y equals -3. So we'd have x plus 0 equals -3, which is x equals -3. And that's our intercept. That's the x-intercept is at -3. So we can come to -3 on the x-axis, and that's going to be a point on the line. This point right here is going to be a point on the line. The y-intercept is where x equals 0. So we can plug x equals 0 into the same equation, x plus y equals -3. So we'd have 0, 0 plus y equals -3. Y equals -3. That means the y-intercept is at -3. Y-intercept at -3. So we go to the y-axis, we plot a point here. Now, 2 points is enough to draw a line. If we have, I just connect the line that way and then extended it out that way. There we go. So the x-intercept's -3, the y-intercept's -3. We can plot the line with that information. To find the slope, we're just playing the same game we've been playing all along. We have 2 points on a line. We start with the left one. We're going down. We're going down 1, 2, 3. And then we're going to the right, 1, 2, 3. So the slope, remember, rise over run. The rise was -3 because we went down. The run was 3. The slope is -1. So all together here, here's what we're looking at. The x-intercept is right here. The y-intercept is right here. The slope we got from doing some math, but we can put all of this together into y equals mx plus b if we want to. Yes, we could rearrange this equation, but we can also use this information to rewrite it in slope-intercept form, which we're going to do. So this would be y equals, the slope is -1, so it would be -x, because we don't write the 1, the y-intercept is -3. So the negative comes from that slope, and the -3 is coming from the y-intercept. Now, we obtained these values by plugging in y = 0 and x = 0. But when you have equations, this is called, I think they call it standard form or general form. I don't remember. I don't like this form of a line, so I don't talk about it too much other than using it to find intercepts. But when you have this form here where x and y are on the same side, this form of a line where x and y are on the same side and there's a number on the other side, what you can really do is you can just ignore the value that you can ignore what you're not looking for. So for the x-intercept, we would be plugging in y = 0, but it's the same thing to just ignore y. Plugging in y = 0 and ignoring y have the same effect. So this guy, duplicate, come down here. If I just ignore y, I get x = -3. And if I just, for the y-intercept, ignore x, we have x plus y = -3. If we just ignore x, we get y = -3. So we have the x-intercept and we have the y-intercept. I'm going to show it in another example so that we can see it in full action. So for this next one, 6x minus 3y is equal to 18. To find our x-intercept, we could plug in y = 0, but again, when it's in this form with x's and y's on one side and a number on the other, we can just ignore the y. Ignore y. And here's what it would look like to ignore y. First of all, let me draw a better squiggle. We have 6x minus 3y equal to 18. Ignoring y means ignoring this, just crossing it out. And you're left with 6x = 18. You can solve for x. This is just a regular old equation. Divide both sides by 6. And you get x equal to 3. The x-intercept is 3. So I come to the x-axis, I go to 3, I plot a point. There's my x-intercept. Sometimes the color coding helps. I'm trying to do a little color coding here. For the y-intercept, we're ignoring x. (6x minus 3y = 18). If we ignore x, we cross out just the 6x. Leave the negative sign there. If this thing is negative, leave the negative. So you get -3y = 18. Divide by -3. We get y = 18 divided by -3 is -6. Oh, I think I did the color coding backwards because I think I did pink for x-intercept, didn't I? I mean, not that it matters. It doesn't matter. This guy was pink originally. So the y-intercept is -6. I come to the y-axis, plot -6. That's enough for me to draw a line. I can draw a line between these 2 points. Boom. Line is drawn. To find the slope, I'm starting with my left point. We're going up 1, 2, 3, 4, 5, 6 units up. And 1, 2, 3 units to the right. So the run is 3. Our slope is rise over run. That's 6 over 3. That simplifies to 2. Our slope is 2. If we wanted to put this together into slope-intercept form, we would, which is y equals mx plus b. We have y equals, the slope is 2. The y-intercept is -6. So we have 2 from the slope and -6 from the y-intercept. You could obtain the same thing by rearranging this equation up here. You could subtract 6x from both sides, divide both sides by -3, but I'm not going to do it. I'm going to do one. There's 2 more examples. I'm going to do one more where I show the process. I'm going to have you try the last problem, and then we'll go from there. So one more time on the plotting the x and y intercepts. For the x-intercept, we are ignoring y. Ignore y. And when we do that, ignoring that, we end up with -2. Let's do this over here. -2x equals 6 because we're ignoring y. To get x by itself, we're dividing both sides by -2. And we end up with x equal to -3. The x-intercept is at -3. For the y-intercept, we're ignoring x. Ignore x. So that means ignoring this. So we have 3y equals 6. Divide both sides by 3 to get y by itself. And we get y equal to 2. So the y-intercept is 2, right up here. That's enough for us to draw a line. The slope of this line, starting at my left point, I go up 1, 2 units up. I go 1, 2, 3 units to the right. Right 3. Right, so the rise is 2, the run is 3. So 2 over 3. So the slope is 2/3. The equation of this line in y equals mx plus b form would be y equals, the slope is 2/3, and the y value, the y-intercept is 2, so the b value is 2. Not that it was asked to do that, just fun to do so. So try out this problem right here. Get the x-intercept, get the y-intercept, get the slope, plot the line, and let's see if there's questions. Beautiful. Perfectly done. Yes, exactly that. Ignoring the y, we'd have 3x equals negative 12. That gives us x equal to negative 4. So our x-intercept is at negative 4. Beautiful, beautiful work. Our y-intercept, we ignore the x. We have negative 4y equals negative 12, which means that the y-intercept is positive 3. And then the slope, you go up 1, 2, 3. You go right 1, 2, 3, 4. So the slope is rise 3 over run. And if we wrote it in slope intercept form, we would have 3/4 x plus 3. Boom. Beautiful. All right. Oops. That's not what I meant to do. Beautiful, beautiful work. Can I answer any questions on that section? Are we feeling okay with that? Okay. So let me write some stuff here real quick. We're going to talk about horizontal and vertical lines. And in that conversation, we're going to talk about positive slope, negative slope, horizontal lines, and vertical lines. So positive slopes. First of all, I'm going to draw this little car because I'm the best artist that's ever existed in the entire world. And clearly this is the cutest little car you've ever seen. Beautiful. Group. I'll make 4 copies of you. All right, so we have a little car. Right, we have a little car. And on a positive slope, if a line has positive slope, it's going to mean that when this little car drives on the line, from the left to the right, as we read, that he would be going uphill. The car drives uphill. So something like y, as an example, y equals 2x plus 1. That's an example of a line with positive slope. So positive slope, car would drive uphill. With a negative slope, it's the opposite. The car would drive downhill. So the little car, he still starts on the left and drives to the right. But now he's driving downhill. As an example, y equals negative 4x plus 1. The slope is negative, is driving downhill. For horizontal lines are lines like this. They run horizontally. They have no slope. The car drives on flat ground if he's driving from the left to the right. The car is on flat ground, and the slope is 0. There's no slope because he's not driving up or down. There's no slope. It's just math. Equations of horizontal lines are always of the form y equals a number. So something like y equals negative 5. There's no x involved at all because there's no slope. The slope is 0. So essentially, whatever the y-intercept of this line is the equation of it. It's y equals negative 5, or y equals a number. Where we run into issues is with this guy. The vertical lines are an issue because if we try to make Mr. Carr drive on this line over here, he's actually just going to free fall to his death. Right? And there's no slope. There's no slope. He's not even driving. He's just falling straight to his death. Car. So the slope is undefined. Undefined slope. The equations of vertical lines are of the form x equals a number. So like x equals 3, for example. So those are our 4 different types of lines. We can either have positive slope, we can have negative slope, we can be a horizontal line, and we can be a vertical line. And important that horizontal lines have a slope of 0, whereas a vertical line doesn't have slope at all. It's an undefined slope. We're going to go ahead and use this information to draw some graphs. And let me stretch a little. Scroll down. So find the slope and x and y intercepts of the line, then sketch the graph y equals 4. So let's say I don't have anything on screen at all to help me. And I'm asked to sketch the graph y equals 4. Y equals a number means this is the line where every point has the y value 4. Every point has y value 4. So the y-intercept has to be not -4, but +4. The y-intercept has to be 4 because all y values are 4, and then it's a horizontal line. So every point on this line has y value 4. Right here, this is -8, 4, -6, 4, -4, 4, -2, 4. This is the line where every point has y value 4. There is no x-intercept, and in nearly every case of a horizontal line, there's not going to be an x-intercept. The exception is if you draw the line y equals 0, which is literally the entire x-axis, in which case then you have every point as an x-intercept, but that's just too confusing. In general, horizontal lines don't have x-intercepts. The slope of a horizontal line is 0. One of the things that a student had told me that they used to memorize whether what the equation of a line was vertical was y equals a vertical line or a horizontal line. Y equals a number. This is a horizontal line, horizontal, because the y looks like an upside down H, sort of. The y looks like an upside down H, but which helps if you can remember that. And also vertical lines, the x, you can kind of like, there's like a hidden v inside of the x. So if it's x equals a number, it's a vertical line. So for this next one, we have x equals -2. This is going to be the line where every point has x value -2. So that's going to be a vertical line at the x value -2. The x-intercept is at -2. There's no y-intercept, and the slope is undefined. You may be wondering to yourself, okay, how does this translate to the slope formula? Or you're not thinking that at all, but now you are because I mentioned it. How does this translate to the slope formula? And I want to talk about it. So let's find some slopes between points. I have x1 will be -7, y1 will be -8. So we have 2 points here. x2 is 3, y2 is -8. The slope formula is y2 minus y1 divided by x2 minus x1. y2 is -8 minus y1 is -8 all over x2 is 3, x1 is -7. -8 plus 8, which is what's happening here. -8 plus 8 is 0. On the bottom, we have 10. So 0 divided by 10, that is 0. The slope is 0. This makes sense because they have the same y value, right? These two different points both have the same y value. So you have one that's at -7, -8, right? Let's say like -7, -8, one right here. And then you have another one at 3, -8, which would be right here. And that's going to create a horizontal line. They have the same y value. I know it doesn't look horizontal, but we're going to really pretend hard with our imaginations that it is. Beautiful. So that's what happens if there's a horizontal line. You end up with a 0 in the numerator. And maybe by the way I worded that, you might be able to see what's going to happen for the vertical line, but let's do it anyway. So our x1 is 4. Our y1 is -1. Our x2 is 4. And y2 is 3. So the slope is equal to y2 minus y1 all over x2 minus x1. Our y2 value is 3. Our y1 value is -1, so 3 minus -1. Then we have 4 for x2 minus 4. And that's what happens. In the numerator, we have 4. In the denominator, we have 0. We can't divide by 0. That's not a thing we do. Uh-oh. Can't divide by 0. So this is an undefined slope. And that means we have a vertical line. Both of these have the same x value. So if I plotted these same points over here, right, we have the point 4, -1, which would be like here. And we have the point 4, 3, which would be here. So the line connecting those is a vertical line because they have the same x value. So that's what happens between points. For horizontal and vertical lines, if you're trying to just find the slope between them. Vertical lines are going to end up with an undefined slope with a 0 in the denominator. So let's see, 0 in numerator. That means the slope is equal to 0. And it means that you have a horizontal line, which means your equation is going to end up being something like y equals a number. If there's a 0 in the denominator, that means your slope is undefined. So it's a vertical line. And the equation is going to be x equals a number. Right? The y kind of looks like an upside down h. And the v in vertical is kind of like hidden up here in the x. It's fun and cool and special. Or maybe just to me. Oops. Let's go scroll down here. I'm going to scroll down and we're going to do these last problems from this section. So for these, we're finding the x-intercept, y-intercept, slope, and the equation of the line. The first, I know, I do too. I love when people come up with stuff like this. This stuff here This is my jam. I love when students bring me stuff that their high school teachers taught them, because high school teachers are always coming up with the best stuff, the best. And so then I get to take it. And that's where this came. That came from somebody who came fresh from high school. They brought that to me. Love it. I really should like write down people's names when I take something from them so I can attribute it to them later. All right. Find some x-intercepts and some y-intercepts. So x-intercept, where we hit the x-axis, that's going to be right here at -2. The y-intercept, where we hit the y-axis, that's 4. This is what we've done all along. From here, starting from the left point, moving, we have to move up 1, 2, 3, 4 units up. And 1, 2 units to the right. So the slope is the rise, 4, over the run, 2. 4 divided by 2 is 2. So the slope is 2. The equation of the line is y equals 2x plus 4. Using the y-intercept for b, the slope for m. We've already done that. That's not exciting. What's exciting is the next two. These came from a different worksheet where I was doing it in a different order, and I didn't feel like rearranging this sheet. So here, this is a horizontal line. Horizontal lines, we know, because h is an upside down y, are going to be y equals a number. The little car would be driving on flat ground. That's okay. So the question we ask ourselves, is the little car okay? If the little car is okay driving, then the slope is 0. It's just flat ground. If the little car is falling to the death, that's when we have an undefined slope. So the slope is 0. The x-intercept, well, it doesn't cross the x-axis at all, so there's no x-intercept. The y-intercept is here at -1. The equation is y equals -1. Whatever the y-intercept is going to be what the number over here is for a horizontal line. The next one is a vertical line. Again, vertical lines are x equals a number. The x-intercept is right here at 2. There is no y-intercept. If the car tried to drive on the line, the car falls straight to their death. There is nowhere for the car to drive. That would be weird. Therefore, we are calling it undefined. The equation of this line is x equals 2, where again, that x-intercept is really telling us what the equation of the line is. So we have 2 minutes left, and we are just not going to get through what we need to get through in 2 minutes. We might have to rearrange some material. We may have to rearrange some material, but I want to take my time going through this. I want to make sure that we're feeling comfortable with lines. Lines are really, really important. So we'll just pick back up on Thursday, and if we get through everything we need to get through, then we do, and if we don't, then we'll push it back. 2.4 is quadratic functions, and there's a worksheet for that one as well. So make sure that you print off that worksheet for 2.4. We'll finish this worksheet on Thursday. If you have questions, you can let me know. I'm going to stop the recording here because the recording doesn't need anything else from me, I don't think. I'll pause it just in case I think of anything. But for the recording people, bye. Hope you have a fantastic day. Resume recording. All right. So one last thing. On Alex, how to use the Alex tool for graphing lines. It's actually super easy. So I have this topic. graphing a line given its equation in slope-intercept form, fractional slope. You're going to select the line tool. Yes, you can use the pencil tool and plot 2 points and connect them, but it's way easier to just use the line tool. With the line tool, you'll place your first point. I'm going to place my y-intercept at -2. So -2, plot. Then I just need to plot one more point. I'm using my slope up here to go up 1, right 4. So starting here, go up 1, right 1, 2, 3, 4. Plot it. Check. Good. One more time. Line tool. Let's do a different one. I already did 1/4. I already did 1/4. Come on. They can't all be 4s. There we go. Y-intercept is -4, so line tool, -4, up 2, 1, 2, right 5. Second point, bam. So all of those problems where you're graphing line, where did my screen go? There you are. All of the problems while you're graphing lines, use the line tool, plot the first point, second point, because you can use the pencil tool, and here's what it looks like. If you use the pencil tool, you would say I'm plotting a y-intercept at 1, and then I'm using the slope to plot my next point, up 1, 2, 3, 4, right 1, 2, 3. You have 2 points, then you take the line tool, and then you're putting them over those points. So you can do it that way, but it is just 2 extra steps that you don't need to do. Anyway, that's the end of the recording now. I'm going to actually stop the recording. Have a wonderful day. I hope that's helpful. I'll probably go over it again at the beginning of class just to double check on Thursday. But okay, stop recording. Bye. Bye recording.